Hello everyone, welcome to today's lecture. Today we are going to talk about programming strategies and methodologies. The strategies and methodologies tell us how to proceed with our task. It can be programming or it can be other tasks and projects. They define for us where we should begin, how we should divide our work, and how we should proceed into different stages of our work and where to finish and so on. So more specifically, today I want to talk about two programming strategies, which was called top-down and bottom-up. These two strategies are also defined in other fields, doing other projects and tasks, but here I want to talk about what they mean when it comes to programming. And I want to also talk about documentation and why it is important to always document the program that you have written. And last, I will talk about developing large systems and what methodologies can be used for developing large systems. These concepts that I'm going to talk about briefly today are very well known to software engineers, because software engineers usually work in a team and they need to know what strategy they should have and how they should divide the work between themselves and what methodology they should choose to start the project and successfully go between the steps until they finish the project. So for programming strategies, let's see what are the top-down and bottom-up strategies. We start with top-down strategy. Here I have put a very simple graphical representation of the top-down approach. In top-down approach, when you want to write a program, you write the main procedure that names all the major functions it needs. I will change the terms procedure and functions interchangeably here. The detail when it comes to programming is not what I care about in this presentation. So what it says is that you start from the biggest notion, biggest problem you want to solve, and you divide it to the smaller parts intuitively, and you need to specify how these parts come together. So at this point, imagine I have started from here and I have divided the work to these three functions, but I have not yet implemented them. I just will specify their names and maybe briefly decide what they will do. And I will also specify how they connect with this bigger function that includes them. Then we go inside each of these functions and decide whether or not it will be itself divided to several other functions, and we will specify how they will be interacting with each other. For example, one function might give inputs to the other function and get return values from that one, and so on and so forth. So this will specify how these functions are actually connected to each other. This is something we need to fix when we are doing the top-down approach. We don't yet implement those functions. We just fix the connections and the general structure of those functions. Then when we continue this process of breaking down each function to smaller function and smaller parts, so at the end we will have very easy functions, small functions whose implementations are almost straightforward because we are dividing the work. And remember that functions are used in order to do a specific task in your program. So when we divide them, the latest functions, the smallest ones, will be very specific and very small. Maybe it is easy to implement them. Then we start implementing the smallest functions, and then we come up from them and then implement, when we have done implementing the smallest functions that, for example, were here, then we come up one level to the one level up and do the implementation here. And when all the implementations at this level are done, we go back to the topmost level and finish any implementation which is left here. So as you see, we go from the top to the bottom. It might be several layers. Here I have just shown 2 layers. One is here and the other one here, but it might continue depending on the size of your project to several levels down. And then from there, you do your implementation and sort of come up and finalize your work. When you have implemented all the various functions that you have discovered are needed for doing your project, then your program is complete and it is ready for testing. Actually, different programming languages are based on different programming strategies. For example, there are some programming languages that fit very much the top-down approach. As examples, we can mention C, COBOL, and Fortran. Another strategy, which is kind of the opposite, is called the bottom-up programming approach. In this approach, you, as opposed to the previous one, start from the very base elements of your system. You need to specify them in great detail. So as you see here, it is intuitive. You need to know what they are. If you want to use this step, you need to explicitly know what are the building blocks of your system. You need to know all the details, and you first start by implementing them, and then you integrate them until you can build the bigger parts of your system. And when all the parts are integrated, you have your all of your system is ready. So you come down and break your system. You start from the base and implement the base parts, and then you integrate them and go up. For doing this approach, you need to have good intuition about what are the building blocks of your system. And you need to know all the details about them to be able to start from them. There are some examples of it. For example, in the real life, Lego bits are very much fitting this approach. So when you put Lego pieces together, you start from the bottom, you build the smaller parts, and then you integrate them together and put the integrated parts together until you have all the objects that you intended to build. Some other programming languages fit this approach. For example, object-oriented programming languages. In object-oriented programming languages, simply the objects that are used in your program are implemented first. For example, imagine you want to implement the grading system for a school. So then you have the notion of students, you have the notion of courses. When you have all the information about these building blocks, you first implement them in an object-oriented language, and then you combine them together and form the interactions between them and integrate them so that you have implemented a software that is used in your school. And there are other software used in other fields than programming, like SolidWorks and Autodesk Inventor, that fit very much this approach. So that was it for programming strategies. When you have implemented the program, what is important is that you not only care about implementation, what is also very important is documenting your work. Documentation is anything you write in addition to your code to help someone else understand how your code works. For example, you can simply have a README file beside your code in which you explain, I have these functions, I have these modules, and they are connected together in such and such ways. Then someone that wants to use your work comes and reads this file and gets an insight about your code, and maybe can then work on it, improve it, or change it, and so on and so forth. But if you don't have any documentation, Any person who wants to know what your code is doing has to read through all your code. It might be very tedious, especially if you have a large code, and it in some cases might be infeasible because the code is too large and the person doesn't have all the knowledge that you have in programming and doesn't need to know all the detail in your code. They might need only some high level information about your code. Having a documentation saves a lot of time for understanding the code without reading the actual code. And it will be especially important if you work in a team. Because when you work in a team, you divide the work between yourselves, and the others do not necessarily need to know all the details about your code. They just need to know what are, for example, the inputs to different parts of your code, what are the outputs, and how maybe they can use your code in their work. When it comes to documentation, it might be confused with commenting the code. We will see their differences in the coming slides. Commenting the code is simply to add some informations inside the code which are not executed, but just give you some information. In Python, we have seen in the previous lecture that we can use the hashtag to write the comments, and comments, as I said earlier, don't get executed. They just have a string that you can read and maybe give you some information. And the comments are preferred to be short. Here you see an example of a comment. So we have here a function which is just simply printing hello world, and in the line which is brown here, we have a comment which explains what this function is doing. These comments do not have any special structure. You can write as you wish. There are just some recommendations to keep them short and simple. And sometimes comments can be used for planning your implementation. Imagine you have an implementation task which consists of several parts. You want to first divide the work for yourself in the code file. It is very convenient to just add it as comments, and then each time you implement each of these steps, you can remove the comment and replace it by your code. And you can use the comments to explain what your algorithm is doing, what your functions are doing, etc. And there are other ways than just writing comments to comment your code. There is something called type hinting in Python, which you can use to explain what are the data types for example, variables and inputs and outputs of your functions. For example, here you see definition of a function which has the name hello name, and it has an input argument. So normally when we want to pass input arguments, we just need to give them a name in the definition of the function. But with type hinting, you give a hint about the type of this input argument. So you see here, the name is followed by colons and then str written. Str is a keyword in Python, which means the data type string. And then we have, after the input argument, is an extra part here, which we don't normally have in function definitions. But this is, again, type hinting about the return data type of the function. It says that this function returns a string, and you see here easily it is returning a string. So we can use type hinting to give hint about the type of the variables, because type of the variables in Python is not explicit. In other programming languages, you explicitly have to give your variables a specific type. For example, a variable which is a string will always be string. And in time you are defining that variable for the first time, you need to write that, for example, I have a string called S, or I have an integer called A or B. You have to specify that. But in Python, because we don't have that, it might be useful to use type hinting to specify, to give guidance about the types of the variables in your program. And in Python, we can use docstrings to document our code. You saw that the comments did not have any special structure. You could write anything you wanted in any format that you needed. You just had to have hashtags in the beginning. But docstrings are built-in strings that when you write them correctly, can give documentation for your code. And when you put docstring for a function, for example, then you can use the built-in function help to print out the content of the docstring for that specific function. So it can help the user to know, for example, what are the input parameters to the function, what will be the output, etc. So here we see an example of a docstring. We have here a function definition, and it simply is multiplying two input arguments. In these gray lines, we have a docstring. You see it starts with 3 double quotation, and it also ends with 3 double quotations. And then inside it, the input arguments are specified, and guidance is given that they should be numbers, and also the return values are specified, and some description is given about what they are. And then later on, you can print the docstring of any function you want. For example, here you see it says for the function multiply, get its docstring. It is specified in this way, underscore, underscore, doc, underscore, underscore, gives you the docstring, and then it is printed out. So you see that in console, it looks like this. It prints the whole docstring as a hint. The docstrings have a special structure. For example, input arguments should be defined in a certain way, return values, and first you should have a bit of text about what the function does. The docstring are also used in other programming languages, and in any programming language, they will have their own standards about how you need to specify them. And they are very useful later on. For example, you can print all the docstrings that are in your project and put them in a file. Then it can be, for example, a textual file. You give it to other members of your team, then they know simply what functions are in your implementation, what variables there are, what are the inputs and outputs, and then maybe they simply just use your functions by importing, and then they, according to the docstring, they exactly know what are the inputs and outputs, and they can use your function correctly without even looking at your implementation, because your implementation might be very big and it's not convenient to write it, to read it for other members of the team. Now let's talk about development of large systems. When you want to develop a large system that requires programming, then you need a team that consists of several roles and several people. For example, you need a product manager, you need several software developers, software engineers to do the actual programming, and you need software testers, because we have discussed every time you program something, you need to, of course, test it extensively to make sure that it is working correctly. And when the system gets larger, the tester becomes more and more important. It might get as much time as implementation, or even more time than implementation, to test the software and fix the bugs. And besides a team that is needed and it's crucial, you also need a development methodology. A development methodology is the process by which an engineering team will build a given product. It tells them where to start, how different steps they will have in their work, and how they are going to proceed from one step to the other. There are two popular methodologies when it's come to programming. They are called waterfall and agile methodologies. They are also used in other teams than programming. Let's see how they are defined. Let's start by the waterfall methodology. In waterfall methodology, you have a sequential process, meaning that you have some phases and you finish one phase, and then once you have finished it, you go to the next one, and then you finish it, go to the next one, and so on and so forth. There is no cycle in this methodology. The requirement is for using this methodology is that you do a detailed investigation and full research about the product that you want to implement. For example, imagine you have a customer who wants to develop a software for managing the schools and grades of the students. You need to do full research about what they need, what they want to store, what they want to process. And then once you know their needs, you need to fully document the project in advance. This step is very important to document that with all the details, because as we said, the waterfall methodology is a sequential process. Once you have done one step, you're not going to go back to it. So you have to do it completely. For documenting a programming project, there are different things done, and the software engineers are experts in this front. They, for example, use use case stories, and they list all the features and all the outcomes of the system, and they specify what are the different parts of the system, how they interact with each other, and so on and so forth. The phases of waterfall are divided like this. So first comes the analysis. Then once the analysis of the system is done, you go to the design phase. We will see in more detail how the work is done in each phase. After analysis and design, we go to the implementation. And after implementation, you have to test your system to make sure that it is working as it should. So in the first phase, we have the analysis phase, which is in this phase, the research will be done. No implementation will be done yet. You need to just find out what your customer needs, what the one who is ordering that piece of software needs. And the requirements need to be analyzed, and you need to fully understand the problems. For example, what is the problem that they want to solve using this system? What are the problems that you might find when you want to implement this system? And you need to ask all the questions that you have, all the things that are not clear for you from the customer, and make sure that you get the answer you want in order the work is completely clear for you to do. There cannot be any ambiguities. For example, your customer cannot simply say, okay, I need a program that manages the grades of students in my school. This is very vague. You need to know all the details. How are the classes formed? Who is eligible to put a grade for a student? What are the different roles in your school? And many other details. Let's see an example. Imagine you are asked to develop a customer address book using the waterfall methodology. First, you need to discover always the requirements. Assume the user gives you that I have the following list of requirements. I need to create new contacts in my address book, view my contacts, and import contacts from other programs, email my contacts, and also add pictures to represent the contacts. In the waterfall methodology, when you are supposed to implement this work, first you need to do all the needs and document. First, you need to document all the needs of your customer and make each of these requirements very detailed. They are not detailed now. There is a lot of ambiguity when it comes to any one of them. You need to divide the work for each of them and come up to a lot of details until everything is completely clear for you. So in the analysis phase, the engineering team takes these requirements that the user has specified and analyzes them. And they pretty much need to ask questions from the customer. And the role of product manager here is that updates the documents and solves and writes the questions that are resolved by contacting the customers. The next phase in the waterfall methodology is design. So once your analysis is done, you need to design a technical solution. So far you just knew the problem, not the solution. In this phase, you need to come up with a technical solution. For example, what programming language maybe you are going to use, how are you going to arrange your database, how are you going to ensure the security of the system, and so many other technical details. And then you need to document also your solutions to each requirement, and the member of the team need to review the documentation to validate that they are actually a solution to the problem, because there might be some faults in the design, there must be some requirements that are not addressed in the design. The design needs to be approved of the members of the team. So let's go back to our customer address book example. In the design phase, the engineering team creates a design for all the functionalities that are expected from the system. For example, how should the database be designed? The database is a space that will collect all the data. In this case, it will collect and arrange all the data about the contacts. And how should it be designed? There are many different designs. And then they will also mock-ups and workflows. Mock-ups are used in manufacturing different sorts of products. They are simply a model of the system or a prototype of the system. They are not functional. They just show how your system will finally look like, but they don't have the full functionality. They just are a model. Now let's see what is the next phase in the waterfall methodology. It is actually the implementation phase. So once you have done analysis to realize what the problem is, and then you have designed your solution, you can start implementation. Before you start the implementation, design must be approved by all the team members. So here comes the technical implementation, and implementation is actually the shortest phase, because all the details of implementation is actually already defined in the design phase. Just that the code is not written, but you know what parts your program will have and how these parts are connected together and what is the input to each function. For example, what will be the output and so on and so forth. Here you just need to implement them by a programming language. So let's again go back to our address book example. In the implementation phase, simply the engineering team will implement the functionality, will develop the functionality and prepare it for testing. The last phase in this methodology is testing. So again, we need to make sure that before starting this phase, the previous phase, which was the implementation, is complete. And the testing phase is inevitable. It is always essential before you can give the product to the customers. And the input to this test phase are design documents that the product manager in this methodology had already prepared in the design phase. And so you need both the design and the product that you have developed, and you compare these two against each other to see whether or not the developed product is respecting your design. And so this now the work is passed to the software testing team. They will use these design documents and create test cases. We have already talked about test cases briefly before. Test cases simply are a set of different tests. In each test, you have specific inputs and the outputs that you expect the system to give back to you. And then you give the test inputs to your system and receive the outputs and compare it to the expected output. If there is any deviation, you need to find in your program where is the problem, find the bug and debug it. For example, the testing team will run the tests and report the test results to the implementation team so that they fix them. And then again, this last phase might need to be repeated several times so that all the problems are solved. So when it comes to developing programs, there is one issue. There is always change in the requirements of the customers. Sometimes the customers change their mind and want to add some functionality to the code. Sometimes while you are doing the project, you learn some features that can be changed. You sometimes need that some solutions that can be used that fit better. Or sometimes on the way of doing these phases, you realize that the problem is actually more difficult than what you had expected in the beginning. So the problem with waterfall methodology is that it doesn't tolerate changes. Change is very expensive in the waterfall model. Imagine, for example, you come to the implementation phase and realize that something in the requirements has changed because the customers need something else. Then you have to go to the beginning, do the analysis once more, and change the design according to the new analysis and change the implementation. This will be very expensive because in the waterfall methodology, we first finish each phase and continue to the next phase. Waterfall methodology has some benefits. For example, it has a straightforward planning and designing. This is because once you are doing the analysis, you fix everything with your customer and both of you agree on what are the requirements. So then you know exactly how much of work you should do, and then you can plan for the rest of your project. And because you have from the very beginning a picture of the whole system, you are able to do a better design. And you can easily define the scope of your work because you first fix your analysis and then fix your design. So you know how complicated your work is or how simple your work is. There are no surprises. And in this way, you can easily estimate the costs because because as soon as you have done the analysis, the scope of your work is clear, so then you can easily estimate the costs. And when you are proceeding in the different phases of the waterfall methodology, you can clearly measure the progress. For example, have we finished the first phase or not, and in how much time were we supposed to finish this phase, and how are we now compared to that estimation? Are we behind our schedule? Are we faster than our schedule? And so on and so forth. And in this methodology, the roles of the team members are defined, so everyone knows what is their responsibilities in their project, and they are usually not going to change. But the agile methodology is very different from the waterfall methodology. In the agile methodology, you have an iterative approach to product development as opposed to the sequential approach that you had in the waterfall methodology. And the agile methodology is performed in a collaborative environment. The team members collaborate with each other more closely. And the teams are self-organized, and the roles of the team members can change depending on how they feel more comfortable to work and which role fits them better. And the agile methodology is also very good in producing high quality software. And sometimes with agile methodology, we can have a project which is more cost effective, and it will be done in a shorter time. Let's see how this methodology works. In this methodology, we have the notion of backlog. Backlog is simply a list of prioritized requirements. This is a dynamic list, and the most important items are completed first. You remember in the waterfall methodology, we had also a list of requirements, but this list was a fixed list and it wouldn't change. But you see here, a backlog is dynamic. It can change. Items can be added to it, and they can be removed from it. And in the waterfall methodology, how you implement the list of requirements was not really the question, but here in agile methodology, you start from the most important requirement and then follow to the next ones. This is also a key difference between these two approaches. And in agile methodology, you have iterations, several iterations, or they are also called sprints in your software development. It means that you will have the sequences of steps as in the waterfall methodology, but you will go fast through a complete sequence once to just implement one or a few of the requirements, and then you sort of loop through these phases again to implement the next requirement. And the iterations in this methodology are usually short. They are about 1 to at most 4 weeks. During each iteration, all the team members go through a full development cycle, being analysis, design, implementation, and testing. And then at the end of the iteration, they demonstrate their work to stakeholders, to customers, basically. But in the waterfall methodology, you would usually wait until the end to show something to your customers. And this is actually risky because sometimes the customers, after they see the final product, they want to change it a lot. This will come with a lot of costs. But in agile methodology, when you do a little work, you show it to your customers. Then if there is a deviation from their needs, you can easily adapt your work. So the change is accepted in the agile methodology as opposed to the waterfall methodology. How is change accepted in agile? One of the key factors is the backlog order, which adjusts the priorities of the functionalities that need to be implemented. The other key factor is the iterations. Because the iterations are short and are not costly, you can easily adapt your iterations and backlog to the changes that the customer needs or your development team needs. Let's see what are the benefits of the agile methodology. So in agile methodology, you have a lot of flexibility. For example, the order of requirements can change. Maybe your customer says, okay, now I realize I want this functionality to be prepared first, and then you continue to the next one, and they adapt it to their budget. Maybe they skip over some functionalities that are not very important and so on. And you have more productivity in this model because you have a dynamic approach, you have short iterations. At the end of each iteration, you have a piece of product which is ready. And there is more transparency. Each time you finish an iteration, you tell to your customer that I have finished so far these functionalities, and your project becomes more transparent. The customer can know what is happening in your project and how far you have done the work. And there is a decreased risk of missed goals, because in any iteration you check the requirements and make sure that you will going to implement the most important requirement next. And since at the end of each iteration, you're going to talk with your stakeholders or customers, then it involves them to a great detail in your process. And this gives them a lot of satisfaction because they know exactly what you're doing, and they can change their priorities if they need to, and so on. The role of project manager in the agile methodology is to create and maintain the backlog. There wasn't any notion of backlog in waterfall, and the product manager was only responsible for creating the design documents and the requirement documents. But here, the backlogs are also added to the role of the product management. And the product management here also provides the requirements for the release. And as I have explained several times, you have the customer input very frequently in this methodology. And what is very important is that in each iteration, you are testing the software you have completed so far. So you have several phases of testing, as opposed to the waterfall methodology, in which the testing is simply left to the end phase. Here you test a lot, which is very good in terms of finding the bugs early and resolving them with a lower cost. But agile methodology comes also with some disadvantages. Because the spirit of this methodology is very dynamic and the requirements can change, and you have an unbounded number of iterations, you cannot plan your resources very well. You don't know how much time you have. Maybe the customer adds to the requirements a lot and your work continues for a long time, or it might be the opposite. There is basically no finite end to your project. And you can, it is difficult to measure your progress, because you don't know when is the end and how many iterations there are left. And also in the agile methodology, the documentation is limited, which is a disadvantage. Let's go to the customer address book example and see how this would be implemented using the agile methodology. So the requirements are as before. The customer says, I need an address book to create new contacts, to view the contacts, import contacts from other programs, email the contacts, and adding pictures to the contacts. We saw the waterfall methodology would start from analysis and proceed to design, implementation, and testing. But in the agile methodology, it is very interesting. We will go through several iterations. For example, in the first iteration, the team works on two of the most important functionalities, which are told by the customer that they are of huge importance, so they are implemented first. For example, creating contacts and viewing contacts. Then this will do all four steps of analysis, designing, development, and testing. And then at the end of this iteration, the team will demonstrate their work with these functionalities to the product manager and also to the customers. And this can be a short iteration. And in the next iteration, they will, for example, implement 3 more functionalities that is required. And again, they go through all the design and development and testing phases. And at the end of this phase, they will show their work to the stakeholders and to the product manager. And at the end, they will run an extra test. So for each of the iterations, we had also a testing, but at the end, it's always preferable to test the whole system all together to see that all the functionalities are working together correctly. And then finally, the product is released. So if you have any questions, please reach us via forum or emailing us or joining the drop-in Zoom sessions. And here I have provided a link for the doodle poll to see which times fits you the most for Zoom sessions. And there are some options there you can choose from. For example, do you prefer office hour or evening hours or weekends, or maybe you are not interested at all? Please enter your choices so that we can plan better. Thank you very much for your attention.